Okay, so hello everyone. I will be waiting for 4 to 5 minutes so that everyone can join. Then we will be starting this live session. I hope my voice is clear to you.
Yes.
Okay. And please just let me know that my screen is visible to you all.
Yes, ma'am, it is.
Okay. Okay, so we will be starting this session in 2 to 3 minutes so that all of you like whoever wants to join the class may join the class. Then we'll be starting in next few minutes. So I hope that we people have already watched the week 3 lectures. Because if you have watched the all the lectures, then only you will be able to understand the operations and all the calculation which we are going to be discussing in this session. So have you people have seen the assignments for the third assignment which I have given to you? The questions, you have seen it or not? Anyone? Because today we majorly will be we will be discussing uh, the content which has been discussed in week third, and and our target will be that you people are able to solve the assignments and have a good practice of the questions so that you may be able to have a good understanding about the topic. Also, you can also solve the assignments as well as uh, the final paper when you will be appearing for that. So, any one of you have tried the assignment questions, you have seen it, or nobody of you? So, no one of you have seen the questions. I can see there are 3 to 4 students. Anyone of you?
Yes, ma'am, I see the assignment.
Okay. So are you able to solve those assignments, or there are some difficulties?
Yes, ma'am, I'll solve it.
Okay. Okay. So I'll be starting this session. Um, yeah. So, hello everyone. So, my name is Himanshi Singh. I am currently pursuing my PhD from Department of Mathematics, IIT Jodhpur, in broad area of probability and statistics. And I'm your TA for the course Foundations of R Software. So today we will be discussing about the week 3 content, which has already been uploaded on the portal. Okay, so this will be the third live session. Okay, and the schedule for the session uh, is here. So it is basically we are on this third week. We are basically covering 9 to 12 lectures, and yeah, we have done two live sessions already. Okay, so the Google Meet links is given here. Also, the YouTube link is given a YouTube link for my channel on YouTube. So there I'm already uploading the videos. Okay, and the Google Drive is also the link to the Google Drive is also here. So all the presentations and the R scripts I'm uploading there in this Google Drive, so you can access from there. Okay, so we will be, first of all, the plan for this live session will be, I'll give a recap of the topics which has been covered, and I'll demonstrate them in R. Okay, then we will be solving some of the practice examples, and which you people also will be solving with me. And after that, if any one of you have some doubt or something like that, then you can like discuss it with me. Okay, so this is like from the day one I'm saying that whenever I'm writing a syntax, it will be in blue. So this will be the command which are executable in R, and the black ones is a not is the non-executable commands. Okay, so this is basically how to download R. We have discussed in. So I've just included this slides. So if anyone wants it, so this is basically how to download R, and also how to download the R Studio. Whichever you are comfortable with, you can like work with. Okay. So till now, we are basically so in the last session we have discussed about the operations, but majorly we have discussed about how the operations between the scalar and a data vector. So between the scalars we have discussed about the operations, how the operations are how we are operating uh, two scalars with different operators. Okay, apart from that we have also discussed how a scalar and a data vector can be like operated, okay, with different operations. Now today our main focus will mainly consider how to deal with two or three data vectors. Okay, apart from that, if we want to include data vectors and the scalars also, so basically we are mixing all the kind of the elements and we are operating different operators. So we are operating them with the addition. So basically we have already studied this addition, subtraction, multiplication, division. Okay, so we are basically adding the numbers, subtracting the numbers, multiplying the numbers, and dividing the numbers. Apart from that, two more operations also have been discussed in the lectures. That is this integer division, so which basically returns the quantity when the remainder term is discarded. Okay, and so I will be showing that in R also, and by hand also I will be showing these things. So here we are discarding the remainder, and modulo division is another operation where we are basically, it is returning that what is the remainder. For example, so if I give example here, we multiplication and division. Okay, apart from that, for example, I take this integer division. So for example, at 5 I take 5 and I'm integer division, so this with 2. So basically what it will return me, so if I divide the 5 by 2, so it will be 2 times 4 and remainder is 1. So we are basically discarding the remainder, we are considering this 2. So this is basically will be the output for this integer division. Now what about modulo division? So this is basically the output for the integer division. Okay, and so if I write modulo division, so this will be the output for the modulo division. Okay, so any doubt in this? Any one of you? No doubt. So I hope I'm audible. So am I audible to you all? Just confirm.
Yes.
Okay. So, okay, yeah. Okay, so these are basic two operators which have been discussed. Okay, then some built-in functions are also discussed. So standard calculations are can perform, but there are some built-in functions. For example, maximum. So when so for example, when I have a data vector and I want to see that which of the element of that data vector is the maximum number. So this function can be used. Minimum to find out the minimum element, minimum value. Mean to find out the arithmetic mean for the elements in the data vector. Median is to find out the median for the values. ABS, this is basically used to find out the absolute value. So basically, if the values are negative, then we are taking that positive quantity. So this is basically mod x, if x is an element. Okay. SQRT is to find out the square root. Round is to find out, so where we are basically rounding off the numbers here. Okay. So here in the parenthesis, the element can be a scalar. Okay. For example, a variable, or it can be a data vector. So anything it can be. Apart from it, we have this floor function. So basically, it returns the largest integers not greater than the corresponding element of a vector. For example, for example, if I have a floor 2.5, okay. So I'm taking just a number here, not a vector. I will be discussing about the vectors also. Okay, so function. So basically, what this returns is, so it returns the largest integers, which is not greater than the corresponding element. So it should be less than this element, but it should be that largest integer which is less than this. So this is basically 2. Okay, if I want to use the ceiling function, okay, ceiling. So this is basically opposite of it. So it is the number which is greater than this number, okay, but the smallest integer. Okay, smallest integer which is greater than 2.5, so it will be 3. So this basically is returning this. So this is floor and ceiling function. Apart from this, we have this sum function. So it basically adds the elements of a vector. PROD, prod command. So this basically the function which multiplies the elements in the vector. EXP is to find out the exponential. Okay. For example, e to the power 0, it will give 1. E to the power 1, it will give the value of E. So such kind of things. Apart from those, we have also this trigonometric functions. Okay, so this is sine, cos, tan. A sine means this is the cosec. A cos sec, it is a tan means cot. Sine, so basically these are hyperbolic functions. So these are also inbuilt functions in R. Apart from that, we have logarithmic functions. So log base. So basically this is natural log. Here we have, so it is natural log. Okay, so it is base E. Okay, and log 10, here it is base 10, log 2, so here it is base 2. And also we have the command for if we want to change the base, we have the command for that also. Okay, so these are logarithmic functions. Apart from this, so these are basically the inbuilt functions. So I'll go towards the matrix afterward. First of all, I'll discuss about these functions and the operations in R. Okay, first of all, I will be discussing these operations, then the functions in R, then I'll be discussing about the matrices. Okay, so in the videos, mainly two vectors, data vectors has been considered. That's why I'm here now considering 3 data vectors. So you people have some kind of like a more understanding about the operations. So first of all, I will be discussing that what is happening with addition. Then the same things will be following for the multiplication and for division or for any other operators. Okay, so here I'm considering these 3 vectors, okay, x, y, and z. Now, each vector have length 3, okay. So I'm just first of all running this x, y, z, okay. So control plus return. So basically here I'm doing, or I'm running the codes and all these things in R. If you want to do it in R Studio also, then you can do it. Okay. So this is, so basically what I have done, I have just given the values, or I have assigned the data vectors to variables X, Y, and Z. Now I have data vector X, Y, and Z, which are data vectors of length 6. Okay. So if I want to print it here in the console, so if I print X, so it is giving it. If I print Y, it is giving. If I print Z, so it is giving. So we have these 3 data vectors. Okay. Now I want to add it. Now you can see that here the lengths of all the data vectors are same. Okay. So what I will do, I will just add the first elements of the data vectors, of all the data vectors to itself. So basically I will do -4 plus 2 plus 9, 5 plus 5 plus 3 plus 7, 5 plus 4 plus 8, -6 plus 5 6. Okay. Not -6 plus 4 8. Okay. 7 plus 5 plus 6. So simply, so this kind of things will happen in our, basically we are adding the elements which are, so here we are adding the elements on the same position. So first position elements are added to first position because length are same. So what will be the output basically? So if I want to run this A, so this is basically A means for addition, and what will be the value of A? So it is 7, 15, 6, 18, 2, 13. So basically if you add this -4 plus 2 plus 9, so it will be 9 plus 2, 11, 11 minus 4, it will be 7. Okay. So similarly, all the values gets added and we get this, the vector, which is basically of length 6. So one thing to remember whenever we are operating elements, and if I'm adding or I'm dividing or I'm multiplying two vectors, okay, and the vectors are of various lengths, then the output will be of the length which is basically maximum. Okay. So here the lengths are same, so there is no issue. Okay. If the length are different, so if the length is different, then there can be two scenarios. Okay. If the length of the shorter vector is multiple of the length of the bigger vector. Okay. So for example, if I consider xm, ym, and zm, 3 vectors again, where the length of the first vector is 6. Okay, let me run it first. So here, if I display it, so x, m, so it is a vector which is of length 6. Okay, then again y, m, so it is a vector of length 3. Z, m, this is a vector of length 2. So you can see that this ym, the length of the vector ym, can multiply the length of the vector xm. The length of the vector zm can multiply the length of the vector xm. Okay. So what will happen here? So what will happen here? So let me go to. Okay. So if I have such kind of scenario, so I have C. So what is it? 4, 5, 6, 7, 9, 7. So 4, 5, 6, 7, 9, 7. Plus another vector I have which is of length 2, 3, length 3, and the elements are 2, 3, and 4. Another vector, it is of length 2 and it is 9, 7. So the bigger vector is of length 6 here. So if I'm adding here, so if I operate these two vectors first, okay. So if I see, so here the addition will be like 4, 5, 6, 9, 7. Okay. Now we have 2, 3, 4. So so first place we have this 2, 3, 4. But now the places are empty. We do not know. So this vector will again repeat itself. Okay. But it has 3 values and there are 3 empty places because basically it is a it can divide this, the length. So the length of this vector can divide the length of this vector. That's why it will be like 2, 3, 4 here. So when it will be, when we add it, so it will be like 7. So, okay. So it will be like this, and if I want to add this to this also. So here if I say 9 7, so this is a length 9 7, so we are basically adding it. So this is of length 9 2, this is of length 2, so it will repeat again itself. So it will 9 will be 9 7, and because there are two empty places, so it will again repeat itself, so it will be 9 7. So because both of these, this and this are like multiple, or it can divide the length of this vector, that's why such kind of thing is happening and no empty places are remaining anywhere. So every place is filled. Now the addition, we can perform the addition. So it will be 7 7 14 18 8. So it will be 9 10 13 2. So the addition will be like simple addition. So we can just see that in R also. So so I'll cross check it by using these two digits. So last two digits will be 2 and 8 of the output. So now I'm running AM. So what AM will be? AM will be, yeah. So it is 15. Okay, not so it will be, sorry, it will be 18 here. The addition of the last 7 4 and 7, so it will be 18. Now this is 9 9 18 19 20 21, so it will be 21. So the last element will be 18, before that it will be 21. So it will be like this: 15 19 16 21 18, and no warning message or nothing like that is happening for this. Now, for example, for a third case scenario, if the lengths are different, okay, but they're not, so here the length of first vector is 6, okay, but length of the second vector, that is yn, it is 5, and length of the third vector is 4. So the lengths are not basically multiple of each other. So let me run it first. So what will happen here? So I got these three vectors. So let me explain it here again. So if the lengths are different, so again I have C 4 5 6 7 9 7 plus 2 3 4 5 8. C 2 3 4 5 8 plus C 9 7 8 6. 9 7 8 6. So let me write it again in this format. So if I 4 5 6 7 9 7, okay, 2 3 4 5 8. So I can write 2 3 4 5 8. Now I have only one empty place here. So this vector will again repeat itself, but we can only write 2 because we cannot write another terms here because there are no terms in the vector which has the maximum length. Okay, so only this vector, only this element 2 will be repeated. No other element will be repeated. So it will be repeated, but no output will be there for that. Okay. Now next we have 9 7 8 6. So 9 7 8 6. Now we have two empty places. So 9 and 7 will be repeated. So only the calculation will be happening with these elements. And now another elements will be there, but because there are no elements present here, nothing is there. So that's why, so here also after 9 7 8 6 9, and because there is nothing, that's why this vector will not have an output. Okay, so this will be the addition of it. Okay, so this is like 7 and 7, 14 15 16. So this will be the last element of the output vector. Is it online for addition? Please, can you elaborate? What are you asking? I'm not able to understand. No, yeah. Okay, it is only for addition. So I'm basically explaining it for addition. It will happen for the multiplication also, and it will happen for the division also, and for the other operations also. I'm just explaining first of all for the addition, and same things will follow for the other operators also. Okay. So I hope it is clear. Okay. So yeah, so we are adding here. So these elements got vanished. So they will not perform any calculation here. And this is added, and this will again be added. We'll get something here, here, here. So basically, we will get output here, output here, output here. Okay. So this will be uh, the output. So we will see the output here in this. So an. So yeah. So here we are getting a warning message. So if I print an will be like an is having some values. So it is of length 6. So basically we were getting 16 at the last place. So here also, so we can cross check like that. So we are getting this vector, okay, of length 6, but here we are getting a warning message. So in xn plus yn, longer object length is not a multiple of shorter object length. So when I'm adding these two, so basically these two when I'm adding, so in this two addition, the longer object length, okay, is not a multiple of the shorter object length, that is 2 3 4 5 8. Okay, so it is not a multiple, so all the values will not be coming here after the repetition. Again, if I, so I'm getting a vector after this, then I'm adding that to this vector, which is again, so the length of the xn plus yn, which is longer. So the length of the shorter vector, which is zn, it is not a multiple of xn plus yn. So which is basically again here. Here also it is happening that in xn plus yn plus zn, the longer object length is not a multiple of shorter object length. So basically it is showing a warning message. However, the operations are the operation are performing, and an is getting a value stored in it, but it is giving a warning message. Okay. Now the same kind of methodology will follow for other vectors, for other operations. So whatever we are finding out with any operation, so this is basically I have discussed for the addition. If I'm finding out in place of addition, if I'm finding out the subtraction, so x minus y minus z. So basically I've taken the same vectors x, y, z, and if I want to subtract them, x minus y minus z, then let's see what happens. So it again, I'm running it, and I'm getting the value of s. So same, it is the vector of length. So here, okay. So x minus y minus z, again it is a vector of length 6. Okay. So here there is no warning message because all of the vectors are of same length. If the different length and the multiple, if I'm performing subtraction with the vectors xm, ym, zm, which are of different length but they are multiple, so here I am again not getting any warning message, and I'm getting the output for it. Okay. See, you can see in the left in the console. Now, if I'm taking these vectors xn, yn, zn again, okay, but they are of different length but not multiple. So again, it is showing the warning message. In the subtraction also, the same warning message appears that the longer object length is not a multiple of the shorter object length. So if I see that value is stored in Sn, but with the warning message. Okay. So this is happening with the subtraction also. Now again, I can also show it for the product or for the multiplication. So if they are of same length, x, y, z vectors, and I'm multiplying them x cross y cross z, then it is, so it is p, the vector p, we can see that it is of length 6. Okay, but we are not getting any warning message because all the vectors are of same length. Okay, if the vectors are of different length but they are multiple, so that is xm, ym, zm, which I have already constructed. So if I run it, so again there is no warning message, and I'm getting value stored in the variable pm, which is of length 6. Okay, now again, this is a multiple, so no warning message. But if I take the another the vectors xn, yn, zn, which are of different length but not multiple, so I'm getting here the value stored in pn, which I can show you, p underscore n. The value is stored here, but again I'm getting warning message. which command are you using? So which command, which for the same length, for the different length, or for what are you getting error? For different length. Okay, so for different length, when the length is multiple, so when the length of the smaller vector is a multiple of the longer vector, or when they're not multiple?
Ma'am, it is multiple, ma'am.
Okay, so what the vector are you taking? So okay, I'll at the end of this session, share your screen and just show me that what is the error displaying and what are you taking, the vectors which you are taking are correct or not. Okay.
Okay, ma'am.
Okay. So this is basically for the product. Now if we take the division, okay, so I'm basically taking the same vectors which I've defined in the initial of this R script. So this x, y, z are the same vectors, and I'm dividing x divided by y divided by z. So if I'm running it again, I'm not getting any error or a warning message, and I'm getting a vector which is of length 6 again. Okay, now if they are different length, that is xm, ym, zm, then if I'm getting, I'm running it, then I'm getting this vector d underscore m. So which is, there is again no warning message. Here you can see one thing when I'm dividing. Okay, so basically if there, so x divides by y divides by z. So if I divide, uh, so if I divide three numbers, then there is order of division. Okay, so 2 divides by 3 divides by 4, for example. So first if we divide 2 by 3, then we divide the output by 4, then the output is different, and if we change the order, then the output is different. For example, if I am taking x divides by y, so let me take it in the console. So see, here I'm taking x divides by y divides by z. Okay, so I'm getting an output here. Okay, if I'm taking again x divides by y divides by z, and if I apply a bracket in the second term, so basically what it means, that we are first dividing y by z, and then we are dividing that output with x. Okay, then the output are different. So basically you should understand that what you are performing. So this does not happens with the addition, and this does not happens with the multiplication, but this is happening with the division. Okay, so because in the multiplication, whoever you divide, there is no problem. Okay, because that operation is commutative, but this does not happens with the division. So you should ensure these things, that what you are doing, if there are two division operators, then the division, if you are not specifying any bracket or something, then the division will follow from left to right. So first of all, x divides by y will be executed, then that the resultant quantity will be divided by z. So basically this kind of the process R is following. But if you specify that first divide y by z, that implies you just give a bracket here. So first you want to divide y by z, then you want to divide x by that resultant quantity. So you must be aware of this thing, that both the commands are not same. Is it clear? So here I am taking three things. So here for the first d, for the same length, I am taking simply x divides by y divides by z. In the different length, I am taking bracket in the first side, and the for this d, and I'm taking the bracket in the last side, in order to emphasize that both the things are, or the things are not same. Okay. So if I emphasize that brackets are here and brackets are here, both are different things for the same vectors also. Okay. So this is the thing I want to emphasize just. So we have considered dm. So we have seen that for the dm, since they are of different length, and the shorter length vector are multiple of the longer length vector, so that's why there is no warning message. But if they are not multiple, for example, if I'm taking x and y and z and again, then let me see. So here again there is a warning message because they are not multiple. So here if I want to see that what is the value of dn, so this is basically the value is coming, but we are getting a warning message. Okay. Now same things happen with the operations like integer division. Same kind of things will happen for this also. And again, these operations are also not commutative. So basically, if you want to operate, so basically the R will follow from left to right. So first this operation will be done, then this operation will be done. So R will follow from left to right. But if you want to do first this operation you want to execute first, and then this operation you want to execute, then you have to emphasize it is using the brackets, just like for division. Okay, so this again, if I see this integer division, so this di, I am storing the values for x, y and z I'm operating. So again, there is no error message or no warning message. And if I want to see the values, then it is again I'm getting the values. Okay, also so this is basically I want to show you that how when you are getting a warning message and when you will not get a warning message, what the operators are doing, how the operators are working, I will be discussing in the practice examples, that what is happening with the operators and how the values, how these values are coming. Okay, here I made my main concern is to tell you about the warning message, that when you will get a warning message and when you will not get a warning message. Okay, so this is again different length and multiple. So if I run it again, I'm not getting any warning message. And if I execute it, so I'm getting a vector. Okay, okay, if they are not multiple, again if I am executing, they're not multiple, again I'm getting a warning message because the lengths are not multiple. And if I want to execute it, so I'm able to execute it. Okay, I'm getting values infinity all over, but I'm getting a warning message because the lengths are not multiple. Okay, so how I'm getting these values, I will be discussing them through the practice examples. Okay, now again I'm getting a module, I'm having this operation modulo division. So modulo division again will have same kind of scenario. So if I find it, so dm, so they are of same length. So if I execute dm, so I'm getting a vector of length 6. If the lengths are multiple, then I'm not getting any warning message. Okay, then also I'm getting a vector. If they're not multiple, in that case scenario, if I run it, so again I'm getting a warning message. However, I'm getting a vector, the values are stored here, dmn, in dmn the values are stored here, but I'm getting a warning message because of the that length are not multiple. Okay, so this is basically I've shown you all the operations, and in all the operations same kind of thing is happening, that if the lengths are same, then there is no warning message. If the lengths are multiple, then there is no warning message. But if they're not multiple, then there is a warning message. Okay, so we will be considering one practice example for this concept also. In that concept, in that question, you will be having a better understanding about this concept again. Okay, now apart from this, some built-in functions. For example, if you want to add, then xyz is a, so okay, so if I have x vector, y vector, z vector, and if I want to combine all these three vectors, then I can use this command cxyz. So basically what cxyz is doing, if I show you x comma y comma z, we already have x y z vectors. If I combine them, so this is basically I'm getting another vector. So it consists of uh, all the elements of the vector x, y and z. So all the elements, all the numbers I'm getting in a single vector basically. So if I sum it, so it basically sum all the values of this vector. So it is 61, it is coming, so it is summing all the values, so all the values it is summing up, and it is giving 61. So this is to add. So this is an inbuilt function in R to add the elements of a vector. So it is basically adding -4 plus 5 -6 plus 7 -9. It is adding all the values, and it is getting the, I'm getting the answer, that is 61. If I want to product each of the value, if I want to product, then this command prod, and inside the parenthesis I'm having this vector. So this again, it is giving me a number. So basically what it means, as we have already discussed, this means 3.6 minus 3.687093 multiplied by 10 to the power 12. So this quantity basically means that. Okay, this e plus 12, this basically means into 10 to the power 12. Okay. Okay, if I want to find maximum, so if I want to, in this vector, if I want to find maximum, so you can see from here that 9 is the maximum quantity here, I think. Yeah, 9 is the maximum. So let us see. So yeah, it is displaying 9 only. And if I can see that here minus 9 is the minimum quantity, so this min command, so it is again, so this, yeah, minus 9, it is returning minus 9. Okay, if I want to find out the absolute value, so it what basically it will do, it will find out a vector whose all the values are positive. So this is a vector, we have c, x, y, z. But if I find out the absolute values, so it will convert all the negative values to positive. So it is basically 4, 6, 9. Apart from this, that all the values are same. So if I run it, so it is basically giving me all the positive values. If I want to find exponential, so it basically find out, so what it will give, it will give e to the power 4, e to the power 5, e to the power 6, e to the power 7, and it is basically applying e to each of the element of this vector. So if I see, so these are the values I will be getting when we apply exponential. So it will apply e to each of the value in the vector c, x, y, z. Okay. Okay, then if I want to apply log, then again I can apply log to this vector, and this will apply log to each of the vector. Okay, so this is basically log. So okay, you know that log is basically a function. The argument of log cannot be negative. So we also have some negative values in the vector c, x, y, z. That's why wherever the negative values are there nan are produced. So there are 3 places, there are 3 negative values in the vector c, x, y, z. That's why 3 nans are produced, because in the argument of log, negative value cannot be considered. That's why this nan is produced. Apart from that, we have all the values. So basically we are applying log to each of the values in the vector. Same, if I want to have base 2, then this command, so it will again, so will produce nan, but the values will be different, because here we are taking the base to be 2. Again, if I take the base to be 10, then same thing, nans will be produced, but the values of log base 10 will be different. Okay. Now, apart from this, we have this square root. If we want to find out the square root, then we have this command sqrt. So if I run it, then you can see again here the nans are produced because we have negative values. And if we square root those negative values, then in R, the nans will be produced, because we do not have any concept for the square root of the negative values in R. Okay, we are only tackling with the real numbers. So here nans are produced. Apart from that, square root of each number is displayed here. Okay, so let me consider y, where the y was a vector where all the values are positive. That's why I'm considering only this vector square root of y. So let me store a value r to store value of the square root of y to r. So I have a vector r here. If I can see here, this is a vector r which is of length 1, 2, 3, 4, 5, 6. Okay, so this is a value, this is a vector r. Now to round off, so you can see here various numbers in the left hand side in the vector r. Now I want to round off this r. So here it is 1.4. So it will round off to, so it is basically, if I want to, okay, round r, let me run it first. Here you can see, so 1.4 is basically less than 1. That's why it rounded off to 1. 1.7 is greater than 1.5, so it is 2. This is 2, it is already rounded up. 2.23 is less than 2.5, that's why it is rounded off to 2. 2.8 is greater than 2.5, so it is 3, and this is 2 only. So it is basically rounding off the number. Now if I want to see the floor and the ceiling function, so if I find the floor function, so it will basically give the value or the integer which is less than the number. So 1.4 is a decimal or a fractional, so it is basically not a natural number, or not an integer. So an integer which is less than 1.4. Okay, so which is less than but greatest among all the integers, which is less than 1.4, so it is basically 1. So it is giving 1. For 1.7 again it is giving 1. For 2 it is an integer, so it will be same. For 2.23, so the smallest integer, which is, so no, the greatest integer which is less than 2.23 is 2, so it is giving 2. 2.8, for 2.8 also it is giving 2 because it is the greatest integer which is less than 2.8, and 2 is an integer, so it will give the same. So this is basically the floor function. Now for the ceiling function, it will give the integer which is greater than the value and which is the smallest among them. Okay, so it is a ceiling function. So for 1.4, it is giving the 2 because it is the 2 is greater than 1.4 and it is an integer. Okay, and it is the smallest among the integers which are greater than 1.4. And for 1.7, again we will have 2. For 2, it is an integer 2.23. So greatest integer, sorry, the smallest integer which is greater than 2.23. So it will be 3. So it is giving 3. And for 2.8, again it will be 3. And this 2 is an integer, so it is returning the same value. So these are basically the functionalities for this floor and the ceiling function. Okay, we will be dealing with these functions in the practice examples also. Okay, so now I will be discussing about the matrix. Okay, so okay, matrix. So basically, the matrix is a rectangular array with the m rows and n columns. Okay, I don't know why it is. Okay, yeah, and I'm able to write. Yeah. I'm taking the matrices only. First of all, I'm discussing it here. Then I'll be discussing it in R. Okay. So matrix is a rectangular array with m rows and n columns. So basically, I have this kind of. So this is a matrix. Okay. So for example, let me take a particular matrix: 1, 2, 3, 4, 5, 6. So this is a first row. This is a second row. Okay. Let me write it like this. So this is a first row R1. This is a second row R2. Okay. This is a first column 1, 4, which consists of, so it is C1. This is a second column C2, column C3. Okay. So this is basically the matrix where the horizontal entries are the rows and verticals are the columns. Okay, so in general, if we say, so here it is 2 cross 3 matrix. Okay, it is 2 cross 3 matrix. But in general, we say that a matrix is a rectangular array with m rows. So m can be a natural, m is a natural number, of course. N is again a natural number. So with m rows and n columns. So m can be any number like 2, 3, 4, 5, 6, or whatever. N can be any natural number. Okay, now total number of entries. How many total number of entries are there? That is m cross n. Okay, so there are, for 2 cross 3 matrix, we have 6 entries. Okay, so total number of entries in a matrix is m cross n. So for this we have 6 entries. For this we have 6 entries. Okay, now elements of a matrix can be characters or numbers. Now here I have written numbers. Now the entries of for a now entries in a matrix can be a number. Now for example, we have also studied this vectors. Now when we are dealing about the data vectors, then the elements for the data vector can be a string or a character. So for the matrix also, the entries can be a character or real numbers, but we will be mainly interested in real numbers, because if we want to add two matrix, subtract two matrix, so for that operations we need basically the real numbers. We cannot do those operations with the characters. So we will be mainly focusing for the real matrix. Real matrix means the elements or the entries in the matrix are real. Now here the entries can be like in negative, can be positive, can be rational, can be irrational numbers. So there are basically real numbers. Okay, the entries in the matrix. Now, what is the how to define a matrix? So how we define a matrix in R. So how, if I want to get a matrix, how I will be coding it in R. So if I want to assign a matrix to a variable x, so x is equals to matrix n row is equals to n. M means the number of rows in a matrix is m. So in place of m, you can give a particular choice for a natural number. N col is equals to n means a particular choice of a natural number for number of columns, comma data. So whatever data you want to fit in. So here for this matrix, what you will do, you will give n row is equals to how many rows? 2 rows. So in place of m, you will write 2. Okay. In place of n, you will write 3. And data is equals to this. So whatever data you want to fit in, you just write it here in this. Okay. Now data, if you want to fit in, now how you want to fit in. So it can be fitted. So this matrix I can have, apart from this, I can have 1, 4, 2, 5, 3, 6. No, not like this. Okay, wait. So I'm having this matrix to be 1, 2, 3, 4, 5, 6, and I'm going row wise. So 1, 2, 3, 4, 5, 6. I'm going row wise here. Okay, I want to go column wise, then it will be 1, 2, 3, 4, 5, 6. Okay, now how to identify that by what command I will get a which matrix. Okay, so if I write by row is equals to true, means I'm assigning the entries by rows. So basically I'm giving first I'm filling the first row, then I'm filling the second row. So basically if by row is true, so then I'm filling it like this for by row to be true. So I'm filling like this. So I'm filling first the first row, then the second row. Okay, if I write by row is equals to false, or if I write nothing, so by default it is fitting the entries by columns. So basically it is first filling the column 1, 1, 2, then column second, then column third. Okay, so this is basically the how the entries are getting fit in a matrix. Okay, if I want to access an element of a matrix, so the command xij. So what ij basically is, I is the ith row and j is the jth column. So for example, if I want to get the element of the matrix which is 4. If I want to get this 4, so it is at which place? So it is second row, okay, and second column. So how I can access it? So if this matrix is x, so I will write x 2, 2 in order to access this element 4. So it will give me output 4. Okay, I'll be showing it using the R commands now. Apart from this, also we have some more functions in matrix. So I want to know the dimension of a matrix. Dimension means so how many rows, how many columns. So it has basically 2 cross 3. So it will display, so this command dimension dimx, it will display the dimension which is for the previous matrix, it is 2 cross 3. Okay, attributes will again display the dimension. Apart from the dimension, it will also display some more things, but those things we will be discussing after the next week lectures. Okay, but for now it will display the dimension for you. Okay, the function end row x, so it will basically tells the number of rows. Is it possible in large data? In large data means if it is finite, then it is possible always. So for that, m and n should be finite. For it, then for large data also it is possible. If m and n are finite, we can get a matrix of always.
Ma'am, I mean, if we upload large numbers like 360 for 40.
Yeah, whatever real number you want here, you can like give it. So you are basically giving numbers now. 1, 2, 3, 4, 5, 6. I am giving it by my choice. You can give any real number, any finite real number you can give, no problem.
Okay, ma'am.
Okay. Okay, so end row basically tells the number of rows in a matrix. Okay, so how many rows are there? So for 2 cross 3 matrix, we have 2 rows. So it will basically display 2 for the matrix I have given before here in the previous slide. N column x means the number of columns. So it will basically give 3. mod of x. So mod of x basically display that so the numbers are there in a matrix, then it will display that the entries are numerical. So basically NUM it will be displaying if the entries are numerical. If the entries are character or string, then it will display character. Okay, so let me show it using R also. So what is basically happening? So I have defined. So see, this is the format. So this is the format basically. We will be following mostly this. But apart from this also, we have different syntax to define a matrix. So I have given the syntax. I have given this for three syntaxes. Not here, in a practice example I have given, so there I will be discussing that. So here what I have given basically, so here I have given this matrix M1, and row I have defined to be 4. So basically there are 4 rows, and n column I have defined 7. So there are 7 columns, and data is 1 to 28. So basically the numbers coming from 1 to 28. Now you can see here I have not written anything for by row. I have not written so by row command I have not written. I have just skipped it. So let us see that what is happening. So if I run it, so if I see that what is matrix M1 now, so this is a matrix. So how the values are assigning? So the values are assigning. So we are assigning the value. So first the first column is filled. Okay, 1, 2, 3, 4 is the first column. Then the second column is filled. Then the third column, fourth column, fifth column, sixth, then seventh. So this is the entries. So the entries are getting filled column wise. Okay. So if I choose by row to be false, then what happens? Let me see it. So if I execute this M2, then I can see here also again I'm getting the same output. So basically by default, if I do not write this by row is equals to false, by default the entries will be getting fixed column wise. Okay, so they are getting filled here in the matrix column wise. The first column is filled, then the second, then the third. Now if I want to fill it using the, so first row I want to fill, then the second row, then the third row, fourth row, then for that I have to write by row is equals to true. So let me run it. So by row is equals to true. M3 matrix I have defined. So let me see. So here you can see that it is coming out to be. So here the first row is getting filled first, 1, 2, 3, 4, 5, 6, 7. Then the second, then the third, then the fourth row is getting filled. Okay, so this is basically the difference of this by row. So the M1 and M2 matrix are same. So if you want to fill it by using the columns, then there is no need to write this by row command. But if you want it to be get filled by using the rows first, then you have to write by row is equals to true. Okay. If I want to have some values which are characters basically. So here these are numbers. Okay, I have given numbers here. But if I want to give characters to the entries, then what? Then let me run it. The matrix M4. Okay, wait. Okay, so M4. So if I run it, so I'm getting a matrix here. So this is basically here I'm giving n row means number of rows to be 2, number of columns to be 3, and in the data I'm giving characters. That is apple, boy, cat, dog, I, fox. Okay, and I've given by row is equals to true means the rows will be getting filled first. So apple, then boy, then cat, row wise we are filling the entries, dog, I, fox. Okay, so here we are having character entries. Now what will happen when we have mixed entries? Some of the characters, some are numbers, for example, like this M5. So if I'm running it, let me run it. Okay, then if I display M5 matrix, then you can see here the numbers are no longer numbers, they became characters. So basically if I'm having mixed entries of numbers and characters, then this matrix will convert those numbers to characters. So they will be no more numbers now, they will be characters, which we will also be seeing by using the mode command. If I want to access an element. Now, if I want to access an element from a data vector, for example, constructed a data vector that was x. So let me display it. So this is a data vector x. That is -4, 5, -6, 7, -9, 7. So data vector of length 6. Okay, now I want to get this element at the third place, -6. Okay, I want to get this element. How will I will accessing it? I will be accessing it. So how I will do that? So I'll write x because it is a vector already, and I'll write square bracket. And since I want to access -6, so this is at third position, so I'll write 3. And if I run it, then I'm getting that element -6. So this is how I access an element from a data vector. Similarly, if I want to access an element from a matrix, for example, not a single element, if I want to access some 2 to 3 elements, uh, for example, so here I have access only single element. Okay, now if I want to access some 2 to 3 elements from this data vector, then for example I want to access first, second and third element from this data vector x, then what I will do, I'll write this command x c1 2 3. So first element, second element, third element. So let me run it. So yeah, I'm getting an output -4 5 -6. So I'm getting all the 3 elements from this data, all the first 3 elements in the data vector. Okay, so this is how I access the element from a data vector. Now, for example, I want to access the element from a matrix. Okay, so now for that, I have to emphasize that what is the row number and what is the column number. And at the first place, I'll write the row number. Then I'll write the column number. Okay, so here this M1 is a matrix. Okay, so I want to display the element which is at fourth row. So this is basically the M1. So where M1 is, so this is the M1 matrix. Okay, the element at fourth row. So fourth row means this row. Okay, and third column. So third column is this column. So this will basically display 12. Okay, fourth row and third column. So let me run it. So it should display 12. So yeah, it displayed 12. I want to access the element at fifth row and second column from the matrix M2. So this is an M2 matrix. So fifth row is not there in this matrix. Second column is there. So for example, if there is, so I have written this 5. Now let me see that what will be the output. So I have run it. So yeah, so it is saying that subscript out of bounds. So because there is no fifth row, so it is showing me an error. Now, if I want to, so again, if I'm considering this matrix M3, okay. So for M3, I'm considering sixth row. Again, because there is no sixth row in this matrix, so again I should get an error. So let me run it. So yeah, it is again giving me error that subscript is out of bounds. Now, let me consider this M4 matrix, which was consisting of the entries which are characters. Okay, so for M4, I want second row element and third column. Second row, third column. So it should be Fox. Okay, so let me run it. So yeah, Fox is coming. In the fifth matrix, I want to get first row and second column. So first row and second column. So it should be boy. Okay, so let me run it. So yeah, I'm getting boy. So this is the way how you can get the elements from a matrix. Okay, by writing their position. Okay, now if you want to know the dimension of the matrix, so for example M1, so M1 I've constructed, so M1 was this. So you can see there were 4 rows, 7 columns. So if dimension dim M1 I write, then it will show me 4 7, means 4 rows, 7 columns. Same thing will be displaying this command attributes. So attributes M2, so it is 4 rows, 7 columns. Okay, now yeah, if anyone wants to say something, you can. Everything is fine. Is there any problem? Is there any problem? Am I audible to you? Okay. 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 So this is basically about the dimensions. Okay. Now, if I want to get the number of rows, for example, so M1 in the M1 matrix, so this was M1 matrix, I had 4 rows. So if I write n row M1, so it should give me 4. Okay, so it is giving me 4. And there were 7 columns. So if I write n col m1, so if I run it, so it is giving me 7. Okay, so this is how you get the number of rows and number of columns. But from this also we have another command which basically says about the mode of the elements, means what is the type of the elements. So whether it is numeric, whether it is a character or what. So let me see. So M1 matrix. So I have defined this M1 matrix here, and all the quantities, all the elements were there, numbers. Okay. So mode of M1 will give me numeric. Okay. Now in M4 matrix, I was defining them to be characters. All the elements were the characters because I have given them the inverted this double quotes. Okay. So there were correct there were characters. So if I write mode of M4, so it will give me character. Okay, but in the matrix M5, here you can see here, I have given some characters, but some were numbers. Okay, but what this matrix is doing, what this when the matrix is displayed, so what is basically is doing, if I write mode of M5, then it will show me character. So basically it is converting all the numeric entries to the character. So if in a matrix, if any one of the entry is character and others are numeric, then it will convert all the numerics to characters. Then we are not able to apply any operation on those metrics. Okay. So this was basically told in the class. So which was basically consist of the operators, how the operators are operating, and what are the inbuilt functions, and apart from that, a little thing about the matrices. So matrices were not fully studied. So we will be doing that in the like forthcoming lectures. Till now, these things and these functions are like discussed. Now, if anyone have any doubt till now, then you may ask, because after that I will be discussing some of the practice questions, and I really want that you people also participate in that. So many doubt? Okay, so if there are no doubts, then I will be moving forward towards the questions. So yeah, so I'll move forward towards the questions. So basically here I have written a command, this. See, you have written that I want a subpart. So basically here today, I am only discussing about the content which has been covered in week 3rd lectures. Okay. So because I have to move the way the sir is moving. Okay. So he has discussed till now, he has discussed only the up till the mode thing. So I am discussing till there only. Okay, the sub part, how you get the sub part, and how you get the rows, how, or different things about the matrix. I will be discussing those things in the next week live session. Okay, so because those things are not discussed till now. Okay, so here these are the practice questions basically. So here I have constructed, so I have taken this command where, see, you can see that there are various vectors here and various operations. Okay, now as we know that we will follow always the BODMAS rule. Okay, we'll follow always it. We'll always follow it, BODMAS rule. Okay, now you can see, let me write it here. So we'll follow BODMAS rule, which we have already discussed before. Now here you can see this is the operator which is power. Okay, order. Okay, so we'll take this as first. So first of all, we will finding out this. After that, we'll take the division. Okay, this will be at second place. Then we'll add it, third place. Then we'll subtract it, fourth place. Okay, so first of all, we'll finding out the power. So if you see, it is 4 to the power 1 because the vectors are of same length. Okay, so because they are of same length, so we just take first position vector of the first position element of the first vector and first position element of the second vector. So it is 4 to the power 1. Okay, 6 to the power 2, 8 to the power 3, and 2 to the power 0. So after this, outcome will be this. So after this first operation. So what it will be? 4, 36. It will be 5, 1, 2, and it is 1. So this will be the outcome for this first operation. Okay. Now this is the second operation. So this is basically we are dividing this vector by this vector. So here we have, if I write the second operation, this one, or this one, this second operation. So we are basically having this 5 is dividing 15. So we will have what will have 3. Okay, 15 divided by 5 will get 3. 6, we are dividing 12 by 6, so it will be 2. Now the vector is like over, there is no more entry, so it will repeat itself again. Okay, now it is of length 4, it is of length 2, so they are basically multiple. So this 4 is multiple of 2, so it will again repeat itself. So it will be again 5 and 6. So 5 again will divide 25 by 5 times. 5 5 are 25. Then 6 will divide 18 as 6 3 times. Okay, so this will be the output for this second operation. Okay, now let me write it. So it will be 4,
And
36.
ma'am, can you explain once more?
So I'm saying, so which operation? First operation or the second one?
Second one.
Okay, second one. So let me write it explicitly. So for example, second, I'm taking this vector 15, 12, 25, and 18. Okay, now I'm dividing this vector by C5, 6. Okay, now this is of length 4. So first element we will divide by 5. So this is 15 by 5. Okay, second element we will divide by 6. So this is 12 by 6. Now the elements, now there are no elements in this vector. So this vector will repeat itself. So it will repeat itself means it will repeat. So the third position will be 5 and fourth position will be 6 because it will repeat itself in the same order. So that 5 will divide this 25 by 5, and that 6 will divide this 18 by 6. Because the vector, the length of this vector divides the length of this vector. Okay, so basically it will repeat itself 5 and 6. So it will again is repeated, and 5 will divide 25 and 6 divides 18. So this will be the resultant vector, which is basically this. Is it fine?
Yes, miss, it's fine.
Okay. Now I'll write the whole operations. So first vector, this operation, after operating this, I'm getting 4, 36, 5, 1, 2, 1. Then I have, so this is C, and then I have 10, 5, 7, 9 minus this I have, and this I have operated. So this was coming to be 3, 2, 5, 3. See, 3, 2, 5, 3. Now first I will add. I'll add these two, then I'll subtract here. So if I add, I'll get 14. So in the next slide, so I'm getting 14 here. 36 plus 5, I get 41. 41 here. 512 plus 7, so it will be 519. 519. 1 plus 9, so it will be 10. Okay, minus, I have this vector 3, 2, 5, 3. C of 3, 2, 5, 3. Then I'll subtract it. So final, the output will be 14 minus 3, so it will be 11. 41 minus 2, it will be 39. 519 minus 5, so it will be 514. 10 minus 3, it will be 7. So the output should be this. Okay, so let us see it in R now. Okay, so what is the output coming? So this is just cross check that whether you are doing the R is also doing the same thing or not. So this is the question 1. I have already written the same things. Okay, just don't copy from the slides to here. Just write it by your own hand, because otherwise there may be some errors. So just write it by your own hands in R. Okay. So if I'm running it, so I'm getting the same output: 11, 514 and 7. 11, 39, 514 and 7. Okay, so this is the way by which we will be follow. So here we are basically following the BODMAS rule. Is there any doubt in this question?
No, madam.
Okay. So which step I should repeat? Which step are you not understanding? Matrix? So step matrix and all those things, and I have asked you before to. Okay, so which part of the matrix you want? Okay, you just joined. So like there is like a limited time I have, and I have 10 more questions. Sorry, 9 more questions. What you can do, you may see the video lectures. So I will upload them. Apart from that, if there is a time at the end of the session, I will uh, discuss it with you. Apart from that, I also have some questions on metrics. So when I'm discussing this question on metrics, then I will explain it again. Okay. Okay, so this again is a same kind of operations we are having, and I want you to tell me first that which operation in this command we will be operating first. So which will be the first operation which will be executing in this command? Which one?
Exponential.
Exponential. We are not having exponential here.
Power.
So this is basically the power operator. So we are operating this first. After that power operator, we will be going towards the division. Now we have two divisions here. So this will be the second one, and this will be the one, because R follows from left to right. If the operator is having same kind of nature, then it will follow from left to right. So this will be the second, this will be the third. We'll have multiplication. So this will be the fourth. Okay, then we'll have addition. So this will be the fifth. Then we'll have subtraction. So this will be the sixth. Okay, so let me first execute what it will be. So it is 2, because the vectors are of same length. So 2 to the power 2, it will be 4. 3 power 1, it will be 3 again. 4 power 2, it will be 16. So this of this operation, so it will be 5 divided by 5, so it will be 1. Okay, 6 divided by 2, so it will be 3. 9 divided by 3, so it will be again 3. Okay, now the operator, this vector is gone. Now there is no more entry, so it will repeat itself. And here 6 entries, and here we have 3 entries, so it will repeat itself again. So again we will have 5, 2, 3. So that 5 will divide this 10, so it will be 2. Okay, this 2 will divide 8, so it will be 4. And this 3 will divide this 3, so it will be 1. We are done with the second operation also. Now let me do this third operation. So this is 4, 5, and we are dividing it by 2, 1. So 4 will divide 2, so it will give 2. 5 divides 1, it will give again 5. Okay. Now let me write the results here. So it will be like 1, 3, 3, 2, 4, 1. So it is C. Now here we have minus C, 2, 3, 4. Okay. And no, we have already operated this. So we'll write the resultant. So this is, so we have operated them. So they are coming to be 4, 3, 16. So it will be 4, 3, 16. Okay. Then plus we have operated them. Oh, we have not operated them. So if we operate them, fourth one, so it will come here like. So if we operate them, so there is a product. Okay, wait. Let me, we have already operated that. So let me write this as it is. C minus 3, 8, 5, minus 4, minus 3, 2. Okay. Multiplied by, we have operated them because this was first preference. So before this is a preference. So we have already operated this. So it is C 2 comma 5. Now we are having multiplication. So we'll give first preference to the multiplication. So here it will be C. Now it is 3 into 2 minus 3 into 2, it will be minus 6. 8 into 5 will be 40. Itself again. So it will be 2, 5, and there are 6 entries. So it will repeat itself. So it will repeat itself 2 times. Okay. 2 times because there are 6 entries here. So it will be 2, 5, 2, 5, 2, 5. So when this 2 is multiplying to this, we are getting 6. 8 is multiplying by 5, we are getting 40. Then 5 is multiplying by again with 2. So it will be 10. Minus 4 is with 5. So it is minus 20. Minus 3 with 2. So it will be minus 6. 2 with 5, it will be 10. So this is will be the resultant. Now these vectors will be same. 1, 3, 3, 2, 4, 1 minus C 4, 3, 16. Okay, so 4, 3, 16. Sorry. 16. It is not getting incorporated here. Okay, so forget it. I'll write it on the next slide. So I'm getting this. Okay, so yeah, so I was getting C133241. So C133241. Okay, minus. So let me take this minus inside. So it will be like plus C minus 4 minus 3 minus 16. So minus 3 minus 16. Okay. And it is minus 6, 40, 10. So it is minus 6, 40, 10, minus 20, minus 6, minus 20, minus 6, and 10. Okay. So now we are having additions. So basically, wait a minute. So which question we are doing? It is question second. So yeah. So what is happening basically? Let me write it in this format. So I am having one. Since see here we are having this to be length 3, so it will again repeat itself. Okay, so when it repeat itself, so it will be C1 3, or I can just add it. So it is 1 minus 4 minus 6. So C of 1 minus 4 minus 6 comma 3 minus 3 3 minus 3 plus 40. Okay, then third entry 3 minus 16, so 3 minus 16 plus 10. Okay, now the entries are exhausted, so again it will repeat itself, and this is of sixth length, this is of sixth length, it is of 3 length, so it will repeat itself one more time. So it will be minus 4 minus 3 minus 16 at fourth, fifth and sixth places. So again we'll have 2 minus 4 and 2 minus 4, and at fourth position minus 20. Okay, then 4 minus 3 minus 6, then 1 minus 16 plus 10. Okay, so what it will be? It will be 6 minus 6 minus 4 is minus 10, and 1 minus 10 is minus 9. Okay, 3 minus 3 will get cancelled, so it will be 40. 10 plus 3 is 13, minus 16 is minus 3. Okay, minus 24 plus 2, so it will be minus 22. Okay, and this is 6 plus 3, so sorry, 6 minus 3 is minus 9, 4 minus 9 will be minus 5, and 10 plus 1 here it will be 11, minus 16 will be minus 5. So this will be the output. Is there any confusion in this question? Is there any confusion in this question?
No, madam.
Okay, so let me see this in R. So if I run it in R, okay, so if I run it in R, so I'm getting the same output, that is minus 9, 40, minus 3, minus 22, minus 5, minus 5. So it is correct. Okay, question 3, if I talk about, so here, this is a question 3. So here it is saying that which of the following command execute with warning. So there I was saying that there is a question on warning, that in which of the command there will be a warning. So if I see the first option, so here first of all it is important to see that which operator will be operating first. So this operator will be first one. Okay, this operator, because this is a power operator. When it will operate, so both are of same length, so no warning. Okay, so here no warning will be there. Okay, so or I should write no warning. So no, I will write, okay, no warning, because they are of same length. Then after that division will be displayed. So the execution will be at this operation. So this is of 1 2 3 4 5 6 length, this is of 3 length. So this is basically 6 is a multiple of 3, so there will also be no problem, no warning. After that this division will be operated. So after, so they are of same length again, so there will be no warning. Okay, so here I am getting a vector of length 6. Okay, and here I am getting a vector of length 3. Okay, plus I have this vector of length 6, and this is a vector of length 2. Okay, now again when this operation will be done, so this is a vector of length 2 already done, we are done. Now here this is a vector of length 6. So this is of 6 and this is of 2, which is again a 6 is a multiple of 2. So there will also be no warning. So here we have vector of length 6. Here we have vector of length 3. Then we have a vector of length 6 again. Okay, now we have 3 vectors, one of length 6, one of length 6, and and 2 of length 6 and 1 of length 3. And 3 is again a multiple of 6. So sorry, 6 is a multiple of 3. So that's why there will be no warning. So in this option, there will be no warning. Is it understood? Is it? Okay. Now in the second one, again, you can see, okay. So in this one, again, this operator will be first be operating. So these are of same length, 4 and 4. So there will be no warning. Then after that division, so this is 4, this is 2. So this is again no warning. Okay. Then this is here, this is 2, this is 2. So there again will be no warning. So here I'm getting a vector of length 4 minus vector of length 4, vector of length 4 and vector of length 4. So here again also I'm getting a vector of length 4, here vector of length 4 plus vector of length 2 multiplied by a vector of length 2. So here I'm getting a vector, here in the total I'm getting a vector of length 2, and these are of length 4. So because 4 is multiple of 2, again there will be no warning. Okay. Now in the third one, if you can see, here we have 1, 2, 3, 4, 5, 6, again 6 length. This is of 2 length, 3 length, 3 length, 6 length, and 2 length. Okay. So if I see here, this will be operating first and there will be no warning because there are same length. Okay. After that, this will be operating same. This is of 6 length, this is of 2 length, no warning. This is of 6 length, this is of 2 length, so there will also be no warning. Okay, here I'm getting a vector of length 6 minus a vector of length 3 plus a vector of length 3 multiplied by vector of length 6. Again, we are having all the vector. So finally we are getting a length vector of length 6 and 3, and because 3 is 6 a multiple of 3, it will also be having no warning. Okay, now let me consider this. Now here, because I have taken this example to show you that here also we have taken vector of length 6, vector of length 3, and the vector of length 2. Okay, here also in the option D, I have taken vector of length 6, vector of length 2, vector of length 3. But here, what is happening basically, this is a power operator. So here I'm getting a vector of length 3. Okay, so there will be no warning. Now, when I'm dividing this, I'm getting vector of length 6. So there will be no warning. Here, I'm getting vector of length 2. No warning. But what is happening here? Here it is a vector of length 3 and here it is a vector of length 2. So there will be a warning because we are multiplying a vector of length 3 with a vector of length 2. So there will be a warning. So it is not necessary that if I'm getting all the operations like vector length 3, 2, and 6, and because 3 is a 6 is a multiple of 3 and 2 both, so there will be no warning. No, that is not the case. If somewhere it is happening that we are operating two vectors, which one is of length 3 and other is of length 2, then there will be a warning. Is it okay? Yeah. So yes, there will be a warning. So this is the correct option. Okay. So let me consider this next question. So how much time we have? Okay, we have half an hour more. Okay, so for this command, what will be the correct output? So here we are using maximum function, minimum function, square root, and absolute functions. Okay, now you should see that where are the brackets. So basically these are this. Yeah, if two vectors are of same length, then there will be no warning. Yeah, correct. But here in this question, we have this vector of 3 length and this vector of 2 length. So the result of this operation will give us a vector of length 2. And here we have vector of length 3. So when they will be operator, then there will be a warning. I hope I'm clear. Okay. So yeah, we are here having these functions: maximum, square root, minimum, absolute functions. But here the main thing is that where the brackets are. So these are the important things. So you can see that maximum, and we are opening this bracket here. Here it is the opening, but here we are closing it. Okay, so we'll find out the maximum of the output for this. Okay, again in the square root function, we are opening the square root here and closing it here. So we are basically here for this. We are first of all find this operation, then we'll find out the maximum. Here also first we'll find out this operations, then we'll find out the square root. And then we'll have resultant values. So first of all, we'll find out these functions, what the resultants are. Then we have this plus, and then we have this division. So this division will be operated first, then this addition will be operated. Okay, so first of all, let me find out the values for the functions. So what is the first of all the argument? So this is basically, so what is this? So the argument, for example, let me write this here. So it is C15279 minus C24 divided by C12 plus C10245. Okay. Now here we can see there are multiple operations. So we'll first go with the division because it is coming in the first place in the board mass. So 2, 4 divided by 1, 2. So it will be 2 here and 2 here. So 4 divided by 2, it will give 2. 2 divided by 1, it will give 2 here. Okay. Plus 10, 2, 4, 5, 15, 2, 7, 9. Okay. So when we are adding this, so it will be 25. First of all, we'll add it. This is 4. Okay. 7 plus 4, it is 11. 9 plus 5, it is 14. Minus 2, 2. So it will be 25 minus 2 will be 23. 4 minus 2 will be 2. So since this is a vector of length 2, this is a vector of length 4, it will repeat itself again. So it is 2, 2. So I should not write it here. So it will repeat itself. So 11 minus 2 will again be 9. And 14 minus 2 will be 12. Okay. So this will be the resultant for this. Okay. Then I need to find out the maximum. So I need to find out the maximum. Okay. So which is 23. Okay. Now the second one, this one, square root of this quantity. So which is what? C 14, 7 to 23, I think. 223, yeah. And we have minus minimum of this. Okay. So we have minus minimum of minus 245. So I can directly write my minimum of this quantity will be minus 2. Okay. So I can directly write minimum of this is minus 2. Okay. And I need to find out the square root of this quantity. Okay. So it will be what? So it will be, so it is plus 2, 14 plus 2. So it will be square root of 14 plus 2 will be 16, 7 plus 2 will be 9, 2 plus 2 will be 4, 23 plus 2 will be 25. So what it will be, the square root will be applied to each value. So it will be 4, 3, 2, and 5. This one. Now what is the final operations? So the first vector was, so first it was resulting to 23. So we have, what we have? 23. Okay. 23 plus, and we had this vector square root of this quantity. So which is 4, 3, 2, 5. Okay. And divided by now absolute of this one. So absolute of this one will be a vector 2, 1. So it is C of 2, 1. So first we'll operate this division. So it is 23 plus. So it is 4 divided by 2, that is 2. 3 divided by 3, 3 divided by 1 will be 3. Again, it will repeat itself, 2, 1. So 2 divided by 2, 1. 5 divided by 1 is 5. Okay. Now we'll add 23 to each of the element. So it will give us 25, 26, 24, and 28. So is there any doubt in this question? Okay, so I'll just quickly do it in R. Okay, so I have already written it. So yeah, it is giving me 25, 26, 24, and 28. Okay, so yeah, now I'll move forward for the next one. So I have all these questions only, which consider these operations only. Okay, yeah. So this is, now we are using the ceiling function, minimum function, maximum, and floor function. Okay. Now in the first line, you can see we have a ceiling function. Then in the argument of the ceiling function, we have all this quantity. So basically the bracket is opening here and closing here. Okay. And here we are having this argument. And for the floor function, again, we have this one. So first of all, we'll evaluate the quantities in the argument of the ceiling function, then in the argument of the floor function, then we'll see. So if I write this here, so it will be minimum of this product. Okay, so minimum of product, so not the product, this power. Okay, so 4 raised to the power minus 1 by 2. So if I see 4 raised to the power minus 1 by 2, so this basically is 1 by under root 4, so which is basically 1 by 2. So it is basically the first argument of this is 0.5, because 1 by 2 it is giving 0.5, and this is square root of 64, so which is 8. Okay, so minimum of this divided by minimum of 9 raised to the power 1 by 2 means it is root 9, so it will be 3. See, I should write. So it will be C 3, comma 4 to the power 2, so it will be 16. Okay, so what it will give, and we are having the ceiling function, so I'll do that afterwards. So first of all, what this quantity will be, so the numerator will be minimum of this one, this is 0.5, and minimum of this one is 3. Yeah, the double asterisk, so this operator and this operator both are same. So it is 0.5 divided by 3, or you can write it like 1 by 6. So what it will be, it is 0.16, something like that. Okay, 0.16 or something like that. Now, so ceiling in the ceiling, it is ceiling 0.16. So since it is a ceiling function, it will return 1. Okay, now let us consider this second part. So it is basically product of this to the power this. So basically product is opening here, and where is it ending? It is ending here. So first of all, we need to evaluate the quantity which is inside it. No, it is not ending here, it is ending here. Here floor function is ending, and here the product function is ending. Here, from here to here. Okay, so we should first of all find out the vector which is coming here, and then we'll product it, then find the floor function. Okay, so let me write this C of. So what it is, so fifth question we are doing. Yeah, C of 3232 to the power 3, 2, 3, 2 to the power C of 2, 3. 2, 3. Write it. Divided by maximum of then again we have inside the maximum C of -1, 3, minus 9. C of -1, 3, -9. Yeah. Multiply by minimum of 4, 3, 6, 8. Minimum of 4, 3, 6, 8. So the main thing about these questions is how the brackets are placed. So you need to write or you need to perform the operations according to that. Then it is closed. Minimum is closed. Yeah, minimum is closed. After that, minimum is closed and then the maximum is closed. So yeah, it's like that. And then after this, when we operate this, then after that we need to find out the product. So it will be product of. So what is it? It is 3 to the power 2. So it is basically C is 3 to the power 2, that is 9. 2 to the power 3, 8. 3 to the power 2 again, that is 9. And 2 to the power 3, that is 8. Because it is repeating itself, because it is of 4 length, it is of 2 length. Divided by maximum of. Again, in the argument, what is C of -1, 3, -9 multiplied by minimum of this, and minimum of this is 3. Okay, and this one. So product of C of 9898 divided by, so it is maximum of, this is C. So when we multiply it, it will be -3, it will be 9, it will be -27. Okay. Now maximum among them is 9. Okay. So it is product of C of 9898 divided by maximum is 9. Is 9. Now, so it will be product. So it will give us, because each entry is divided by n and we are producting it, so it will be 9 by 9 multiplied by 8 by 9 multiplied by 9 by 9 multiplied by 8 by 9. So this is 1, this is 1. So it is basically 8 by 9 square. Okay. So what is 8 by 9 square? It will be 0.79 something. Okay. And we need floor function of it. So floor of 0.79. So it will give floor because it will give 0. Okay. So we found out the ceiling function. It was coming out to be 1. Floor function is coming out to be 0 and we are adding it. So 1 plus 0, it will give 1. So the output will be 1 for this. Is there any problem in this question? So all the operations we are doing according to the brackets which are there. So just make sure that you are operating in a right way. So yeah, I'll just show it in our fifth question. So it will be this one. So it is giving output to be 1. Okay, now I have included many questions actually. So here, this is again, all those functions are we are using. So same kind of calculations can be done for this function. So for this command, so you can do it by yourself. I will be uploading, so I'll do it by yourself. Just kind of practice, because we do not have that much of time. I have discussed similar kind of problems. So similar problems we have discussed already. Okay. So by same way, you can just find out. Now this also okay, so this I will be this is this extra operations here. We have not discussed this operation, so I will be discussing this operation here. So I will be discussing this operation here, then you just do it by this, do this by yourself also. Okay, so do this also by yourself. I'll just discussing this operation. Now here what is happening, so we have these operations plus, minus, and we are having this operation also. Now in the BODMAS rule, this operation was not there, these operations were not there, only division was there, but these operations were not there. But we, before this addition and subtraction, so before addition and subtraction, we perform this operation and this operation. So these operations will be performed before addition and subtraction always. Okay, so we'll perform this operation. So this is basically, so if I write this first one, that is C51, 66, 57, C51, 66, 66, 57, 38, 4. So this basically, what does this operation do? This operation just after ignoring the remainder, it gives the other term. So basically what is happening, we are dividing 51 by 4. So 4 1 times 4, we are giving, it is 11, and it is 4 2 times 8. So whatever the remainder is, we are not concerned about it. So it basically gives us 12. So it is giving first entry to be 12. And 66, when we are operating with 44, sorry, 4 with 66, so it is 4 1 times 4, it is 26, it is 6 times 24, it is giving, so it is 16. When similarly we operate 57 by 4, it is 4 times 16, so it will give us 14. And if we operate 38, then 4 9 times 36, so it will be, yeah, it is ignoring the remainders, it is only considering this values, okay. So when 4 is dividing by 38, so it will be 4 9 times 36, so it is giving 9. So the first operation is giving us value 12 16 14 9. Okay, then we'll perform this operation. Okay, because before addition we should perform this operation first, then addition subtraction will be operated. So 25 44, okay. So we'll have C, it is 25 44 22 34 25. So as I have already performed this operation, so there is like you are able to understand this. So 25 44 22 34 22 34, if I'm, it is integer modulo C 4546, 4546. Now we have two vectors of length, same length. So this will be operated on this. So what will be the output? So it will be 4, when we divide 4 by 25 by 4, so it will be 4 6 times 24, remainder will be 1, so it will only give us 6. Okay, 5 8 times 40, 5 8 is 40, so it will give remainder 4, so we will always be getting 8 because we are ignoring the remainder terms. 4 5 times 20, so it will be 5. 6 6 5 6 5 is 30, so it will be 5 again. So it is giving us 6 8 5 5. So the second one is done. Okay, then we are having the third operation, this one. This operation is the modulo operation. Okay, modulo division. So it is C43 36 67 88 36 67 88. and this is modulo C2133. C2133. Now this is the operation where we are getting the remainders. Okay, so 43 when we divide it by 21, so it is 22 two times. This is 42 and we are getting remainder to be 1. So here the remainders will be printed. So it is 1 comma, when we divide 36 by 33, so remainder will be 3. Okay, then again, since this is of 2 vector length, so it will again repeat itself, 21 33. So when 21, when we divide 67 by 21, so it will be 20 to 21 2 times 42 3 times. If I do, then it is 63 and remainder is 4. So it is 4. And then 88 is divided by 33, so it will be 2 times. It will be dividing. So 33 is 88. So it is 2 times 66. And the remainder is 222. Okay. So these are the remainder that we are getting. So this is question number 8 we are doing. Okay. Then we are dividing this. So C46, 88 50 20, 88 50 20 divided by 2 4 5 10. C 2 4 5 10. Now when we divide it, what will be the resultant? 46 if we divide it by 2, so it will be 23. It will be 4. 88 divided by 4 is 22. 50 divided by 5 will be 10. 20 divided by 10 will be 2. Now we are having these operations. So first vector was 12, 16, 14, 9. So 12, 16, 14, 9. Then plus second was 6, 8, 5, 5. 6, 8, 5, 5. Then the third one was 1, 3, 4, 22. Minus 1, 3, 4, 22. Then finally we had, okay, so it was plus. Then finally we had 23, 22, 10 and 2. Then just add these 3 vectors and subtract this vector, the entries of these vectors from this one. So we'll get the answer. I hope this is clear. You can do the further calculations. Is it clear? So the answer will be minus 4, 5, 13, 34 after the further addition and subtractions. Is it clear how we have done these? We have performed these operations. Okay, so I'll just show quickly in R. So which was which question it was? It was 8th, I think. Yeah. Okay, so if the values are not same, then the vector will be repeating itself. For example, when we are operating this operation, so the first vector is of length 4, but the second is of length 3. So it will repeat itself. So again 21 and 33 will come, and then the operation between 67 and 21 will happen, and 88 and 33 will happen. Or you are what are you asking? You are asking about the vector length, I think. Is it fine what I'm saying? Are you understanding? Okay, fine. So yeah. So let me show it in R. So it was question number 8. So this was the. So it is giving minus 4, 5, 13, 34. So yeah, it is the same thing. Now these are 2 questions. There are 2 questions. So whosoever was concerned about the matrix, I will just give a quick again the formats in which we can write matrix. So basically, what are the commands to obtain the following matrices? So if I want to obtain this matrix, then what you can see here, the entries are like from starting from 7, 8, 9, 10, 11, 12, 13, 14, and going up to 30 with the difference 1. Okay, so this matrix we can write in multiple ways. So for example, I can write it as matrix. Okay, then first of all, I'll write what is row. So n row is equals to how many rows it have? 1, 2, 3, 4. So it has 4 rows. Yeah. How many columns it have? N col is equals to how many columns it have? 1, 2, 3, 4, 5, 6. Yeah, 6. Then I should give the data. Okay, so I should write data is equals to, since the values are from 7 to 30, so I can write C7 30. You can give each vector also 7, 8, 9, 10, 11, 12, 13. That is up to you. You can write also 7 colon 30. It will give the vector from 7 to 30 only. Okay, but here we want the the column is filled. First column is filled, then second column is filled, third column. So we need to not to write anything about the that by default it will enter the values like this only. Okay, so there are other formats for writing this matrix also. Okay, so let me show you that in R. Okay, so yeah. So here I have given some formats in which you can write this matrix. So matrix n row is equals to 4, n column is equals to 6. I can write the whole vector from 7 to 30. Okay, if I run it, it will give me the matrix 7, 8, 9, 10, the same matrix. In place of the whole data, I can write 7 colon 30. In that case also, the initial command is same, but I have just replaced this whole vector with 7 colon 30. So then also I'll get the same matrix, you can see. Okay, okay. Now you can also, what you can do in place of, if you do not want to write n row n col. Okay, so for that, what you can do, just write the data vector first, then write the number of rows, that is 4, and then write the number of columns, that is 6. Okay, you need not to write the n row n column. So first it will take the number of rows only. If you do not specify n row n column, whatever the first choice you will write, it will be the number of rows, and the second one will be the number of columns. But before those, for the number of rows and number of columns, you should give the data vector first. If you will not give the data vector first and write just 4 and 6 before, then it will not display the matrix. So for that, you have to write the data vector first and write the number of row, number of columns directly. Do not need to write n row n column. Okay, so let me see. So it will also give me the same matrix. Apart from this, in place of the whole data vector, I can write 7 colon 30. Number of rows is 4, number of columns is 6. So it will again give me the same matrix. So these are the kind of 4 formats by which you can, instead it is a kind of 2 syntax of the matrix, but I have written here the whole data vector, and here I've written just the column version. So these are the differences, and but the output will be same for all the 4 syntax. Okay, now, so by which we can get the first matrix. Now here in the second question, in this question, it is asking, we need to first fill the rows, not the columns. First we need to fill the rows. So for that, what we will write, we'll write this command, by row is equals to true. Okay, so for that, just include by row is equals to true. Okay, within any of the commands which I have written for this matrix, any. So I am using the this command n row 4 and column 6, then the data vector 7 to 30, then by row is equals to true. So if I run it, So yeah, I'm getting first the column is, the row is, first row is filled, then the second row, then the third row, then the fourth row. So now getting the entries are getting in row wise, not the column wise. Okay. Now the C, in the C part, you can see here two things. So here it is a rectangular matrix with 4 rows and 6 columns. Here it is a square matrix. Okay, that is 4 cross 4 matrix. Okay, you can write obviously with using n rows goes to 4, n col is equals to 6. Sorry, n col is also 4. So because the column and rows are same, so you can write n row 4, n column 6, sorry 4, and all the data vector. So 42, 91, 35, 88, 17, 54, 99, 61, and all the values in the data. Okay. But there is also a simple way to write it because it is a square matrix. Okay, so what is that way? So I should show that in R. So it is matrix, just write the data vector first, and if you write 4 comma 4, it will be same, so it will give you the matrix. But in place of this 4 comma 4, if you write single 4 only, just like this command, if you write single 4 only, then also it will give you the matrix, the same matrix. So you can avoid writing both the things. If the matrix is a square matrix, then only. Okay, so this is also a format to write a square matrix. Only this is true for the square matrix, not the rectangular one. And also here I have written this n row n column, so which is basically the same syntax which I was discussing for the rectangular matrix. So this is the command. Okay, so I hope this how to write a matrix is clear to you. Okay, now I'll go forward for the second question, sorry, 10th question. Okay, so what is a command to obtain the number 47, the third row, the second column, dimension, number of rows, number of columns of the matrix obtained by the command this? See, this is not being taught in the week 3 lectures. Okay, but there are questions in assignment which consist of this command. That's why I'm just explaining you this this command, that what does it mean. So it DAIG just basically means the diagonal matrix. Diagonal matrix means there are some real entries on the diagonal of the matrix, other entries are 0. So it is basically the second, this C45 to 47 is the data, 3 comma 3 is the number of rows and number of columns. So it is basically a 3 cross 3 matrix. Okay, 3 cross 3 matrix where the diagonal entries are this, from 45 to 47. So 45, 46, 47, and other entries are 0. So basically this commands means this. So I am just giving Q10 to be this matrix. Now what the question is basically, what is the command to obtain the number 47? So I want to obtain this number. So what will be the command for this? So it is the third row and the third column. So it will be, since I am giving the name of the vector to be Q10, so it will be Q underscore 10. So it will be Q underscore 10. So it will be Q underscore 10, 3 comma 3, because it is third row and third column. Now how to obtain the third row, how to obtain the column, we have not studied in the week 3 lectures, but I'm just giving you because some of the one or two questions they are there which consist of these terminologies. We will be discussing them in detail in the next live sessions, but these are just so that you can solve the assignment questions. That's why I'm just addressing this. Now how to obtain the third row? So first of all, write the vector name, that is Q10. Now I want to obtain the row. So the first entry means the row. So I want third row. So I will write 3 comma nothing in the second place because I need the entire row only. Okay, so the whole row will be displayed if I write this Q 10 3 comma nothing in the second argument. Okay, if I want to write get the second column, okay, so then for that case I'll write nothing in the row in place of the row, and I'll write 2 in the place of the column. Dimension where we have already done, so it will be dimension of q underscore 10. Number of rows also we have done, so that is n row q underscore 10. Okay, number of column also, so it is n col q underscore 10. Okay, let me just do it in R also. I'll just show you. So in question 10, we just got this matrix. So let me display that matrix q underscore 10, which is basically a diagonal matrix with diagonal entries 45, 46, 47. Now I want to get this 47, so I'll write just q10 3, 3. So it will be 47. Now I want the third row. So q3 comma nothing in the nothing after comma. So it will be the third row. So this is 0, 0, 47. This is the third row. Okay. So can you share this question in the solution as a note? So yeah, actually here I am writing all the commands also. So basically the answer to the question is the same only. So I'll upload the slides on the Google Drive, so you can access it from there. And I'll also be sharing this R script also, so you can get it from there also. Okay. Link for what? So I'm regularly uploading this PowerPoint presentations there in the Google Drive. Okay, so you want link for the Google Drive? Okay, so I'll just paste it there also. Just let me finish this question, then I'll be just pasting that link in the comment box. Okay. So yeah, in the second part we have done. So in the third part, we need the second column. Okay, so in the row in the place of the row, we will not write anything. We write only just 2 in the place of the column. So it is basically giving us 0, 46, 0, so which is basically the second column of the matrix. Okay, now we need dimensions. So for this, I can write this dim q underscore 10. So it will give me 3, 3. So this basically means that 3 rows and 3 columns. Attributes will also give me the dimension, that is 3, 3. This attributes, we will be learning about these attributes more in the forthcoming lectures, because this also contains many other things which we will be discussing in the next lectures. Now the number of rows, so that is n row. So this is 3, and the number of columns, that is n column, which is again 3. So yeah. So this is basically the solutions for these questions. Okay. So now if anyone have any, I'm just pasting this link there in the chat box. Okay, sorry. If anyone meanwhile have any question, then you can ask. Okay, round. Okay, I'll explain round. Other than that, I'm also pasting the YouTube link, and I think Meet link you have. Okay, yeah, round. Okay, so if you want me to explain round, so yeah, give me a vector of your choice. Give me a vector of your choice, and I'll be performing the operation on that. It's okay. Let me consider any vector. So for example, 1, 2, 3, 4. So see, 1, 2, 3, 4. Okay, you are saying, so in the console I'm performing the operation basically. See 1, 2, 3, 4. 1, 2, 3, 4. So this is basically a vector if I'm naming it as, for example, R. So the every element of this vector is an integer. So what will be the round of quantity? It will be the same only. So if R is this vector, okay, if I'm performing round on R, okay, so it will basically give me the same vector only, because there is no decimal or no fractional part in the values, because the values are already integers. So the round command will remain the same, so it will give the same vector. So for the round operation to see what is happening, so you should consider a vector which consists of round up or round down. So that is basically the ceiling and floor function. So there are three functions which are discussed: ceiling function, floor function, round function. So round basically do, so if there is a quantity more than 1.5, that is 1.6, 1.7, such kind of numbers. So for example, let me write it. So round 1.6, for example, you will write, so it will give you 2, because it is more than 1.5. Okay, if you write a quantity which is less than 1.5, that is 1.2, for example. So okay, round 1.2, for example, so it will give me 1. So the thing is, what is happening for the round function? So basically in mathematics, what we do, if the after the point the quantity is greater than 5, then we round off the first digit. If the quantity after the point is less than 5, and then we like for example, after point it is 6, so that's why it is greater than 5, so it is giving 2. But if after point it is a number less than 2, less than 5, so it is giving me 1. But if I'm using the ceiling or floor function, so if I'm using ceiling of 1.2, then it will give me the number which is integer but greater than 1.2, which is just greater than 1.2. Okay, so which is 2. So the ceiling function is giving me 2. But in place of ceiling, if I'm writing floor function, so it will again give me an integer, but which is less than 1.2, but the greatest among all the integers which are less than 1.2. So it will give me 1. So these are the three basic operation to round off the quantity, that is to round, and how the ceiling function is happening and the floor function. Is do I answered your question? Okay, 1.5. So it will give, so for example, round 1.5. It will give me 2. So if it is less than 1.5, it will give me 1. If it is greater than 1.5 or equal to 1.5, it is giving me 2. Okay, so are there any doubts? Now I think you will be able to do all the questions in the assignments. Yeah. So I will be okay. Yeah. So now I will be uploading this lecture on YouTube. Okay, today's session, and the PPT and the R script will be added to Google Drive. And also you have to submit the assignments by 30th of August. And the next session will be that is for week 4 session will be on 18th of August, 6 to 8 p.m. Okay, if there are no doubts, then I will be ending this meeting. If there are some doubts or something like that, then you may like just ask. Okay, so if there are no doubts, then I will be ending this meeting now. Actually, the thing is that this is not in our hand. So the schedule is fixed. Now we cannot change it. So it is, once it is fixed, we cannot change it. Yeah. because it is actually fixed before the sessions are starting. It is fixed by that time only. So if such kind of situation is there, then you have to like watch the YouTube lectures. There is no other option for that. Okay, so